So the title of this talk is Optimising Shiny Apps. It probably should be how I optimise my Shiny app, but we'll carry on. So who am I? I'm Vikki Richardson. I am a senior data analyst with Audit Scotland, but I do have a background in front-end development after a degree in software engineering. I worked as a front-end developer for a while and then went back to uni to do a master's in big data, and then subsequently a professional doctorate in data science. So I'm also, like probably many of us in this room, a collector of university degrees. Slightly menopausal middle-aged woman mother of 4 sons. So soft skills are negotiating. So if anyone needs any top tips on that, come to me. So what have I been doing with R and Shiny? I started with R and Shiny about 5 years ago now with Audit Scotland. I have authored quite a few Shiny apps now in production at Audit Scotland. I really enjoy it and trying to sort of encourage auditors away from just sticking with Excel workbooks and worksheets, moving into the future. And there is a slight rumour going about Audit Scotland that if you stay still too long, I will turn you into a Shiny app. I'm not saying whether there's any truth in that or not. Why do I hope you want to hear from me? Well, I hope that this is a nice case study. I have spent quite a lot of time trying to optimise a rather unwieldy Shiny app. Absolutely take on board that it was me that made it unwieldy in the first place. But if you're starting out on your R Shiny journey, you can hopefully learn from my mistakes. But more importantly, I do want to hear from you. I still have a lot to learn and I'm open to new ideas, and sharing knowledge and collaboration is important, I think, in this kind of job, because sometimes we can become a little bit of an island. So I do enjoy talking to people, so if there's anything that resonates with you today, please just get in touch. So, like I said, I'm going to try and present a case study with an overarching theme of optimisation for a fairly chunky and complex Shiny app that was built up over months, if not years. And I had lots and lots of enthusiasm for lovely analysis that was going on, and admittedly not enough concentration on efficiency and sort of user experience. I'm hoping it'll help someone in a similar position, because I would quite like to have heard about this kind of thing a couple of years ago. And retrospectively improving things can be difficult, so perhaps we can look at how you can start on a path without having to go back and fix things. It is not expert knowledge on Apache Arrow. I'm not a package author or anything like that, but it is about how an ordinary user can harness the power of Arrow. So, what is this unwieldy app that I'm talking about? It's called Ask, in production at Audit Scotland. So Audit Scotland audit the books of all the public sector bodies in Scotland. So all public bodies undergo a financial audit annually, where they present their financial reporting statements and auditors make a judgment as to whether or not it's been presented in a fair and accurate way. And then those financial reporting statements are built from the financial transactions, the income and expenditure transactions of the audited body. So every audited body has a general ledger record of transactions. And financial auditors are required to analyse the general ledger to determine the accuracy of it, or accuracy of the financial reporting statements. So across the public sector, there's multiple different financial management systems. There's multiple accounting standards depending on the sector, so that might be NHS or central government or local government. And when Audit Scotland started looking at using data analytics to do this kind of task, that was when I was doing my master's project. So we set up a really lovely project looking at clustering accounting journals by nature to quickly identify outliers. Journals are the items that make up the general ledger, and it wasn't particularly successful. But during that project, we realised that actually what Audit Scotland really wanted to do was standardise the general ledger of all the audited bodies, so standardise in all those different formats. in different ways, and giving audit teams a much deeper understanding of their audited bodies, all their accounting practices, and that would lead to higher quality audits. And this understanding would then potentially lead on to the kind of analysis that I was wanting to do at the beginning, the scoping of finding the outliers. So I realised I really had to get a much better understanding of accounting journals, but the master's project was coming to an end. Also, but I can't let things go, and like a small dog, I had a loan, and I got a bit too involved and stayed on to do a professional doctorate. And a major aspect of the thesis was standardising the data and developing a platform that allowed audit teams to view the general ledger through different lenses and build up a picture of accounting practices. And building up this underlying knowledge was the first step to creating AI models, as far as I was concerned. That was how we could move forward. So as a buy, Ask has ultimately become a dataset labeler. But you can see from the diagram that it's evolved into a kind of sprawling mass of modules and functionality, and it basically took over my life. So, development focused on the analysis, and it used smallish data sets for testing, and it was a really steep learning curve. Audit Scotland are not a software shop, so we weren't really set up with the infrastructure for development of big apps. I had access to R and an MS SQL database, and I think they thought they were humouring me and I might leave them alone soon. But there was a core group of audit experts, financial auditors and budding R coders that banded around and helped to bring Ask into the world. And we were so happy when it finally became ready for release. After months of coding, testing the analysis, getting the database schema in place, we were ready. So what can go wrong? Let's get a group of 30 financial auditors in a room and train them on how to use Ask. And it was a disaster. And it was literally the worst day I've had at Audit Scotland. Everything ground to a complete halt. I asked Copilot, the title of this talk is Faster Than a Speeding Arrow, and I asked Copilot what's the opposite of faster than a speeding arrow, and it told me a snail on a lazy Sunday afternoon. And that sounds about right for what those poor auditors experienced that day. So it was back to the drawing board for me. So we researched all the ways to optimise a Shiny app. And obviously a big focus for what we experienced that day was trying to overcome some of the limitations of R being single-threaded. That is ongoing, and a big shout out to Russ for the workshop yesterday, taking some ideas back from that. Temporary fix was to deploy an instance of the app per audit team, which is not ideal, but that's where we went. Query optimization. At the time, we thought we had that down, but you'll see in a second that we did not. R code review. So areas where the code was really too reactive, that was one of the things that we focused on. And I think in my earlier enthusiasm for all that lovely analysis, I just acted like our libraries were my very own pick and mix and didn't focus too much on what could be done with sort of base R functions or a smaller group of R libraries. And things like using reactable tables was awesome for collapsing and expanding rows and showing analysis, but it was fairly awful for large data sets without restricting it in terms of rendering on the client side. So the big thing is that Ask is responsive to the project that's been chosen. And each project can import a data set up to about 6 million rows across 42 fields. So we're not talking big data, but it's big enough to cause an issue. And the whole data set was being imported up front because it's R, and the import from the database was not going quickly enough. So yeah, we'll take the hit up front and we'll have the data available, and that'll be good. But it wasn't good. So data import and storage was the thing that we're going to have to investigate for real optimization. So first thing on that was how about adding a caching layer. Yeah, we were quite happy with that. We liked that. We liked the caching layer. Okay, so we started to benchmark the time to import the data directly from the database. And I know that this figure, it looks horrendous. which obviously revealed the fact that our SQL queries were absolute rubbish. However, we're going to slightly gloss over that and concentrate on what we were done inside the Shiny environment. So you can see that it's just unworkable times in terms of a big data set taking about 4 minutes to be imported. So we added the caching layer and we used the memwise package. So we could improve the import time for all those data sets, especially the larger ones, so that was good news. So the memwise package takes the parameters of the function and returns a pre-computed stored answer. So we're reducing the times we have to go to the database, and we're relying on clearly rubbish SQL queries, so that was a good thing. But we can also set that up as a disk-based cache for persistence across all the sessions. So that was definitely going to be useful for us. And then it was just serialized and deserialized when it was read in again. So that was big improvements from sort of 4 minutes down to 30 seconds. So we were happy. Okay, so we had that data in now quicker. And that was fine, but caching that data, that was the data that we were calling directly from the database. And while most of the data that we needed came directly from the database, at setup time for the app, we also had to do a join on another 3 dynamic tables that were created by the users themselves. And that would depend on the type of audit they were doing, the structure of their audit, etc. So, okay, but now we know that caching works, so what do? Do we add an additional layer of caching for that? Do we alter the memwise function? It might be a more complex function, but caching is working, so that might make sense. Or can we compress that down any, or even store it differently? Well, actually, if I'm getting the chance to think about how to store my data, let's really take it back to basics. When we started this project, there was one option, traditional relational database with row-based storage. And each row in that data pertained to an entry in the general ledger. And that was that, made sense. So each row would have information about the system it originated from and the date it was posted and the value of the transaction. But what about alternatives to that? Column-based storage alternatives are supposed to be better for analytics, right? Okay, well, why? So, if the data is stored by row, for example, here, then those values are stored adjacent in memory. But the system field is different to the date field, it's different to the value field. Can't perform the same function on those things that are held together in memory. So, when we're going to do analysis, we obviously have to do some kind of sorting first. But if they're stored by column, then the values that are held together in memory are similar. And we can perform the same function. Well, actually, that seems like something that we're doing a lot, grouping by fields and performing some kind of function on that field, but it also felt like a big change. How can I make it work without rewriting my whole database schema? Is there some way of converting my existing data into column-based storage? And that's where Arrow comes in. So, how do I get my data into a different format? Well, what I do know is that Arrow's a framework which provides a standard in-memory format. And introducing a standard format, it really should be an efficient format. So again, if a single instruction can be sent to multiple adjacent data points in memory, it means that we can vectorize at the CPU level. So that's bound to be efficient, right? And the zero copy aspect of the framework means that there's no need for serialization and deserialization, which can take up a lot of processing time, and it still was even for our memwise functions. Okay, so I know about that. Can I use it in R? Well, each programming language independently implements this standard. So C++, JavaScript, Go, they all have implementations of that. And R, along with Python and Ruby and MATLAB, all bind to the C++ libraries. All right, so I know that R can speak to Arrow. I just need to store my data in Arrow format, and I need to learn Arrow lingo so that I can start to manipulate that data, right? Well, actually, dplyr to the rescue. So dplyr is essentially made up of two aspects: the front-end API, where the user enters all the instructions, and the back-end, which manipulates the data. And because of that split, other packages can take over the back-end depending on the underlying data structure. So if it's a regular R data frame, it's dplyr directly. If it's data from a database, you may have heard of dbplyr, or data tables, dtplyr, and sparkly R, it goes on and on. So the R arrow package acts as one of these backends for arrow format data. So we can use normal dplyr verbs for manipulating arrow data. And there's a comprehensive mapping from dplyr functions to C++ libraries. We don't even need to learn the lingo. So it just keeps getting better. Arrow also allows for lazy loading, because in reality the big benefits of using Arrow in your Shiny app is the fact that you can now manipulate larger than memory datasets. And whilst that's not my major concern at the moment, it may be in the future, and it's all beneficial. So our original table of 6 million rows is accessible, but it's sitting in an R session memory using up only 488 bytes. And when we come to slice and dice the data, we're not pulling it all into memory in order to do that. We can use dplyr verbs on an arrow table and pull in what's needed. So with arrow, you can end a call, a dplyr verb call, in a couple of ways. So compute will keep it in arrow format, ready for the next operation, and collect will pull it all into memory. So when I first started looking at this, loading the data in initially was a big bottleneck for Ask, but there were definitely areas where filtering and joining was also troublesome with the larger data sets. So this was all going to help. Benchmarking on some of those filter operations, and joining was similar, showed that arrow tables were much more responsive, and that all makes sense when you know what's going on under the hood. There are some quirks. So it wasn't all plain sailing. So the mapping between R types and arrow types is good, but it's not bulletproof. I found dates a bit tricky, but nothing's a showstopper. When you're building an arrow table, use a schema. So there's no ambiguity as to what type your particular field is going to be in the data that you create. Window functions aren't available. So things like cumulative sum, moving average, ranking, etc. There are ways around it by partitioning and joining the results back, or doing something really cool like, because of the zero copy integration with DuckDB, we can do on-the-fly processing with DuckDB, which does allow window functions, and then call it back into Arrow with no serialization cost. If you accidentally call a function that Arrow doesn't recognise or it doesn't like, it will pull everything into memory regardless. So that's a thing to keep an eye on. But other than that, I honestly can't speak highly enough of using Arrow for these purposes. And so that's what we did. An additional caching layer, which is now the primary cache actually, and we used the pins package to store that entire cache in Arrow format. And we used the arrow package to manipulate that data using dplyr verbs. So it wasn't, in the end, it wasn't a huge learning curve in the grand scheme of things, and it was also really worth it. So we've gone now to 1.92 seconds for importing the largest data sets that we have. So you can imagine the difference that it's made to our users, where we started off at 4 minutes. Okay, it's probably false of me to say that that's a good comparison, but even compared to the memwise functions, 30 seconds down to 1.92 seconds is all good. So, I don't want to particularly claim the 145 times faster, greater speed, because I do recognise that in reality we had so many issues that were causing those kind of abysmal speeds in the first place. But we are seeing huge improvements, and manipulating the data and performing analysis is generally much quicker, and we're not finding any more spinning wheel of doom inside the app as well. So just lastly, lessons learned. It's difficult. Optimization of the Shiny apps is difficult, and it's very broad. It doesn't rely on one thing, but just consider the analysis that you'll be doing as early as possible. That should help. And Arrow, think about Arrow, because it just does work wonders, in my view. That's it, if anyone's got any.